Now, let us look at second derivatives now, as in we have solved some of the trigonometric function, exponential functions, right? So here, a second derivative simply means that it takes two consecutive derivatives. Okay, so that is d square y by dx square. Okay, which is d by dx of dy by dx. Okay, suppose we have d square by dx square, that a of 2x power 6, which is d by dx of the first term. Okay, that is d by dx of 2x 2x to the power of 6. Okay, so which leads to 12x power 5, and then differentiation of this with respect to x, which gives 60x power 4. Okay. Now let us perform the derivative with respect to theta. Okay. So here we have d square by d theta square of sine theta. Okay. Now first, taking first uh, with respect to theta, right? So this is sine theta, which is cos theta. Okay. And again, differentiation with respect to theta, which is minus sine theta. So let us look at the first problem. So that is d square by dx square of x power 7 minus 3x power 5 and 5x cubed minus 7x. Okay. So d by dx of this whole thing. Okay, let us do that. D by dx, that is the 7x power 6 minus 15x power 4, and this is 15x square minus 7. Again, differentiation with respect to x. So this is 42x power 5 minus 60x cube plus 30x. So that is the final answer. Now let us solve this problem. Okay, here by applying the chain rule, I will solve this. So we will consider u as 3 theta. So so y will be cos u. Okay, so we'll consider uh, and this as dy by d theta as cos 3 theta. Okay, fine. So let's solve this. Now dy by d theta is dy by du into u by d theta, which is d by du into cos u. Okay, and d by d theta 3 theta. So which is this is minus sine u, and this is 3. So this will be minus 3 sine 3 theta. Now again differentiating with respect to theta. So that is d square y by d theta square, that is d by d theta of dy by d theta, which is d by d theta of minus 3 sine 3 theta. Okay. So again, applying the chain rule. So again, considering u as 3 theta. Okay. So u as 3 theta and g as minus 3 sine u. So d square u y by d theta square, which is dg by d theta, that is dg by du multiplied du by d theta, which is equal to d by du of minus 3 sine u and d by d theta of 3 theta. So which is minus 3 cos u, okay, multiplied 3. So this is minus 9 cos u, which is minus 9 cos 3 theta. Now let us solve this problem. So dy by dx is d by dx of ln of x, okay, which is nothing but 1 by x, and d square y by dx square, which is d by dx of dy by dx, okay, which is d by dx of 1 by x, which is d by dx of x to the power of minus 1, which is equal to minus 1 by x square. Now let us find the absolute extrema for the function below over the interval, uh, that is minus 3 comma 5. Uh, so a function f of x is x cubed minus 12x plus 4. Okay. Now let us take the derivative of this. So df by dx with respect to x. So that is 3x square minus 12. Okay. Set the first derivative to equal to 0. So that is df by dx equating to 0. So that is 3x square minus 12 is equal to 0. So we'll get the two values. Let us call these values as xc, which is plus or minus 2. Now take the second derivative of this. Okay. So that is d square f by dx square. Okay. Now, which on substituting uh, the this, so we get as 6x here. Now, next thing is evaluate the second derivative at xc is minus 2 and xc as plus 2. Okay. So d square f by dx square for x as minus 2. So you get 6 into minus 2, which is minus 12. So this is a relatively maximum. Okay. And d square f by dx square with respect to x as 2. Yeah. So you get 6 into 2, which is 12. So this is minimum. Okay. So there is a relative maximum for x as minus 2, which we got as minimum is negative, and relative minimum as x as 2 we got the derivative as positive. Okay. Now, let us evaluate the function with the endpoints which is given x as uh, minus 3 and x as 5. Okay, so let us substitute it. So now f of minus 2 in this function. So this is minus 2 whole cube minus 12 into minus 2 plus 4, which is equal to 20, and f of 2, which is 2 cube, okay, minus 12 into 2 plus 4, which gives us minus 12, and f of minus 3. So this is minus 3 whole cube minus 12 into 3 minus 3, right, plus 4, which gives as 13, and f of 5, that is 5 cube minus 12 into 5 plus 4, so this is 69. Okay, so over the interval 3 and minus 3 and minus 5, the f of x has the absolute value as and absolute extrema as x as x, when x is equal to 5, we get 69, and which is absolute maximum here. Okay, and for x as 2, we get the absolute minimum here. Okay. Now let us find the absolute extrema for the function below over the interval, that is 2 and 4. So your function f of x, 2x power 4 minus 8x cubed. Okay. So let us solve this. Now let us take for the interval, that is 2 comma 4, that is x lies between 4 and 2. Okay, yeah, just given, right. So let us take the first derivative, d by dx of this function, 2x power 4 minus 8x cubed, so which is 8x cubed minus 24x square, and let us take the second derivative. Before that, we'll solve for df by dx equated to 0. So 8x cubed minus 24 x square is equal to 0. So we find x values are 0 and 3. Let us put that as c, xc. So of these, now this lies between, I mean, 2 and 4, 3 lies between it, right? So which is the specified interval. Now let us take the second derivative with respect to x. So that is d square f by dx square. Okay, so that will be 24x square minus 48x. Okay, so again, let us substitute for x as 3. Okay, so we get 72 which is relatively minimum. Okay, so there is a relatively minimum at x as 3. Okay, so where the second derivative is positive. Now let us substitute for these in the function, right? For substituting uh, 3, 2, and 4 in this, right? So let us substitute it. Yeah. So the function f of x is 2x power 4 minus 8 x cube. Okay. So let us substitute for f of when x is equal to 3. So that is 2, 3 power 4 minus 8, 3 cube. So which is 162 minus 216 minus 54. And f of 2 is 2 multiplied 2 to the power of 4 and 8, 2 cube, which is minus 32. And f of 4, 2 to the 4 to the power of 4 minus 8, 4 cube, which is 0. Okay. So for f of x has the absolute maximum when x is 4, and when x is equal to 3, it is the minimum.